I'm Nick Corionalis, and I'm an instructor here at FSI. Student Meghan will be discussing the Doomsday algorithm and an interesting method of determining the ends of the year's days.
Hi, I'm Meghan Combs, and I'm here to educate you, if you're not already, on the Doomsday algorithm. When I first told my fellow Frontiers of Science peers that I was doing my project on the Doomsday algorithm, they were like, "Oh, cool, can you calculate when the world's going to end?" And I can't tell you when that's going to happen, so don't ask me. So the goal of the project is to understand the motivation behind developing the algorithm, understanding how and why it works, and applying it to our Gregorian calendar. Our Gregorian calendar is also known as the Western calendar, or the Christian calendar, and it was first introduced by Pope Gregory XIII, after which it was named. It is the internationally accepted civil calendar, and it's been adopted by a handful of countries over the centuries. It consists of 365 days. It consists of 7-day weeks, and it has a leap year every 4 years. So what is the Doomsday algorithm? It calculates the day of the week of a given date, and it takes advantage of the fact that each year has a weekday upon which certain dates fall, and the dates in the even months consist of the last day of February, April 4th, June 6th, August 8th, October 10th, and December 12th. And the mnemonic to remembering this is just 4, 4, 6, 6, 8, 8, 10, 10, and 12, 12. And the doomsdays of the odd months consist of, depending on whether or not it's a leap year, January 3rd or 4th, May 9th, September 5th, July 11th, and November 7th. And March doesn't have one because on leap years, February 29th is the doomsday, which in every other year would be March 1st. So the mnemonic to remembering the doomsday of the odd months would be I work 9 to 5 at the 7-Eleven, and it's because May 9th is 5-9, September 5th is 9-5, July 11th is 7-Eleven, and November 7th is 11-7. So John Horton Conway was the man who devised the Doomsday algorithm, and he's known for being active in finite group theory, knot theory, number theory, combinatorial game theory, coding theory, and theoretical physics. He was also known to have contributed to many branches of recreational mathematics, including the invention of the cellular automaton called the game of life. And his other achievements include geometry, geometric topology, algebra, and algorithmics. He was born on December 26, 1937. So in order to be able to apply the Doomsday algorithm, we have to know how to use modular arithmetic. And the definition of modular arithmetic is just basically a system of arithmetic for integers that wrap around until they reach a certain value, which is known as the modulus. And it's also known as the remainder theorem because A is congruent to B mod n. And a familiar use of modular arithmetic is just the 12-hour clock that we use. And it's because the 12 is the modulus, and after it reaches 12, it wraps around. And an example of the remainder theorem is because if you divide 7 into 9, we use mod 7 because there are 7 days in the week with the Doomsday algorithm. We divide 7 into 9 and get a remainder of 2, 7 to 8 and have a remainder of 1, and 7 mod 7 is congruent to 0 mod 7 because there is no remainder. And this is just an example of modulo 12 because if you went around the clock 14 times, you'd arrive at 2 o'clock. If you went around 28 times, you would arrive at 4 o'clock. And even if you went around 96 times, you would arrive at 8 o'clock. So the 3 steps of determining any weekday of any given date, you have to first determine the anchor day for the century. And after you've determined the anchor day, you can determine the weekday, the doomsday for all those dates. And after you've determined the doomsday, you choose the closest doomsday date and count the number of days modulo 7 between the doomsday date and the date in question to arrive at the day of the week. So you first have to determine the anchor day, and in order to do this, you find the century number. The century number is the first 2 digits of the year plus 1. So for example, the year 2000 was in the 21st century, and the year 2100 will be in the 22nd century. And then you multiply that number by 5, and you would separately subtract 1 from the century number and divide it by 4 and take the floor of the quotient. The floor of the quotient is basically taking the largest previous integer or rounding down. So the floor of 4.1 would be 4, and the floor of 4.9 would also be 4. And you add these two numbers modulo 7 in the result to offset from Thursday. And we use Thursday because by mathematical definition it is congruent to 0 mod 7. So we know why the anchor day theorem works because we know that 5c represents the offset number of weekdays from the previous century will always be 5. And an example of this is that January 1st of 1800 was a Wednesday, January 1st of 1900 was a Monday, and January 1st of 2000 was a Saturday, all 5 weekdays apart. We know we add this to the floor of c minus 1 divided by 4 because it represents including an extra day for every leap year that occurs every 4 years. And we add the result to 0.17 because, again, it's congruent to Thursday. So after we've determined the anchor day, we can determine the doomsday of the year. And in order to do that, we divide the year's last 2 digits by 12 and allow A to be the floor of the quotient. And we add this to B, which is y mod 12, or the remainder of the same quotient. And we add this to C, which is the floor of y mod 12 divided by 4. And we add the results plus the anchor day to arrive at the doomsday. We know that the doomsday theorem works because we know that it calculates the number of days between a given date in the base year and the same date in the current year, and we take the results mod 7. And depending on whether the 2 days come after the leap day, if any, we know that y plus the floor of y divided by 4 mod 7 will be congruent to the floor of y divided by 12 mod 7. And this is because y represents the number of years that have passed since the base year, and the floor of y divided by 4 represents the number of leap years. And we add the number of years that have passed since the base year plus the number of leap years. And after 12 years, we know that 12 plus the floor of 12 divided by 4 mod 7 will be congruent to 1 mod 7. And because once we replace y with y mod 7, we are discarding this extra day, but adding back in the floor of y divided by 12 compensates for this error. So as an example, I used April 22nd of 2030, and in order to determine the doomsday of that year, you first have to determine the anchor day. So again, in order to do this, we take the first 2 digits of the year, and we add 1, so the year 2030 will be in the 21st century. And then we multiply that number by 5 and arrive at 105. And then we subtract 1 from the century number and divide it by 4 and take the floor of the quotient, and it divides evenly, so it's just 5. And we add these two numbers, mod 7, and arrive at 110 mod 7, which is congruent to 5 mod 7 because 7 divides into 110 with a remainder of 5. And we add this plus 0 mod 7, or Thursday, and we arrive at Tuesday. So the anchor day of this the century 2000 to 2099 is going to be a Tuesday. So after we've determined the anchor day, we can determine the doomsday of the year 2030. And in order to do that, we take the year's last 2 digits and divide it by 12 and take the floor of the quotient. This will be A. We add it to the last 2 digits, mod 12, which will be B. And we add it to the floor of y mod 12 divided by 4. And we add it to Tuesday, to the anchor day. So we get 2 plus 6 plus 1 equals 9 mod 7, which is congruent to 2 mod 7 because 7 divides into 9 with the remainder of 2. And we add this to the anchor day and arrive at Thursday. So all those mnemonic dates will be on a Thursday in the year 2030. After we've determined the doomsday, we know that 4/4 is the closest doomsday to April 22nd, and April 22nd is 18 days away from April 4th. So 18 mod 7 would be congruent to 4 mod 7 because 7 divides into 18 with the remainder of 4. So we have 4 mod 7 plus the doomsday and arrive at Monday. So April 22nd of 2030 will be a Monday. The next example I used is January 31st of 2113, and I chose 2113 so we would get a different anchor day. So again, we determine the anchor for the century, and we take the first 2 digits and add 1, so the year 2113 will be in the 22nd century. We multiply this number by 5 and arrive at 110. And then we subtract 1 from the century number and divide by 4 and take the floor of the quotient, which will be 5. We add these 2 numbers, mod 7, and we get in arrive at 3 March 7, because 115 March 7 is congruent to 3 March 7. And we add it to Thursday, or 0 March 7, and arrive at Sunday. So the anchor day of this century will be a Sunday. After we've determined the anchor day, we can determine the doomsday. So again, we take the last 2 digits of the year and divide it by 12 and take the floor of the quotient and add it to y mod 12, which will be b, and add it to 13 mod 12 divided by 4, which will be c, and add it to the anchor day. So we result with 2 mod 7 plus Sunday equals Tuesday. So the doomsday of the year 2113 will be a Tuesday. So all those dates will land on a Tuesday. So after we know that 2113 will not be a leap year, so we know January 3rd will be the closest doomsday to the 31st, and the 31st is 28 days away from the 3rd, so 28 mod 7 is congruent to 0 mod 7 because 7 divides evenly into 28. So 0 mod 7 plus Tuesday is Tuesday. So January 31st of 2013 will be on a Tuesday. And we can also use the Doomsday algorithm to calculate weekdays in the past. We don't always have to use dates in the future. So I chose Nick's birthday. So again, we determine the anchor day of the year by taking the first 2 digits and adding 1. So the year 1965 was in the 20th century. We multiply that number by 5 and arrive at 100, and we subtract 1 from the century number and divide it by 4, which is 4. So we add these 2 numbers mod 7, and we get to, which is 104 mod 7, which is congruent to 6 mod 7, and we'll add this to Thursday and arrive at a Wednesday. So the anchor day of 1965 was a Wednesday. After we determine the anchor day, we can determine the doomsday of 1965 by taking the last 2 digits and dividing it by 12 and taking the floor of the quotient, which will be A, taking y mod 12, which will be b, and adding it to 65 mod 12 divided by 4, and taking the floor of the quotient. So we result with y mod 7, which is congruent to 4 mod 7. And we add 4 mod 7 to the anchor, and we result with Sunday. So the doomsdays of 1965 will all land on Sundays. 1965 wasn't a leap year, so we know that the closest doomsday to Nick's birthday was a January 3rd. And the 10th is 10 days away from the 3rd, so 7 mod 7 plus Sunday is Sunday. So Nick's birthday was on, or birth date was on a Sunday. I would just like to thank the Toynton Family Foundation for funding my stay and my research here at the Frontiers of Science Institute, Charlie Stoddard for taking a 3rd mentee when I was originally assigned a different project, Crystal Meisel for all the support with the research paper and all the instruction, Benjamin Spitz and Gavin Stewart for all the help with LaTeX, Lori Ball for being the coordinator, Karen Allnut, Maurice Woods, Anthony Gandara, Nick Corianopoulos, just basically all the staff, and my Frontiers of Science peers, and the University of Northern Colorado for allowing us to stay here. Thank you. Can I take any questions? Any birthdays? Chelsea.
Did you ever research like all the doomsdays ever?
Yeah, I've discussed it a few times. I don't know why John Conway just decided to call it the Doomsday algorithm because he can. Yeah. Erica?
So you're like, you find the anchor day or you find the doomsday, what exactly is the doomsday?
It's the day of which all those dates will land on. So it calculates the day of the week of a given. Well, it can. It takes advantage of the fact that a certain day of the week. It takes advantage of the fact that all these dates will land on the same weekday, and every year all these dates will be on the same weekday. Chip.
If I give you a date, you have to year right now.
Yeah.
September 28th, 1995.
95? September 28th?
What is it?
find the century number, which we take the first two digits and add 1. So the year 1995 was in the 20th century, and then we multiply the century number by 5, arrive at 100, and then we subtract 1 from the century number and divide it by 4, and take the floor of the quotient, which will be 4. We add these two numbers, mod 7. This is congruent to 6 mod 7. And we add 6 mod 7 plus Thursday, because it's congruent to 0 mod 7, and that would be a Wednesday. So the anchor day of 1995 was a Wednesday. After we determine the anchor day, we can determine the doomsday by taking the floor of the last two digits divided by 12, plus the last two digits mod 12. Plus the last two digits, the floor of the last two digits, mod 12 divided by 4. So, floor of 95 divided by 12 is 7. With a remainder of plus we add this to the anchor, and 20 mod 7, so that would be congruent to 6 mod 7, because 7 divides into 20 with the remainder of 6. We add that to Wednesday, and 6 mod 7 plus Wednesday would be Tuesday, so you're born on Tuesday. What, do you know if you were born on Tuesday? Really? What's that?
I like you.
6 mod 7 plus Thursday is Wednesday, and then we'll take the floor of the last two digits divided by 1. Oh, no. Oh, this is just, sorry, yeah, you're right, my bad. Yeah, so, sorry, that was, okay, so the doomsday of 1995 was a Tuesday, and your birthday was September 28th, so the closest to that would be September, so 9. So the closest would be the 5th, and the 28th, so it would be 23 mod 7, which is 7, 14, 29, so which is congruent to 2 mod 7. So yeah, you were born on a Thursday because you take 2 mod 7 plus the doomsday, which is Thursday. Sorry.